viewers, Vanakkam, Vandanam, Namaskaram. You are watching Aha Namma channel. It's full and full education and entertainment. Watch the video carefully and learn it everything.
Rational numbers. Properties of rational numbers. Closure, commutativity, associativity, the role of 0, the role of 1, negatives, reciprocals, distributivity. So, we've understood what closure is. Now, let's see what commutativity is. Commutativity checks whether the order of the numbers in the operation is important. Let's check commutativity for whole numbers. Let's check for addition. 4 plus 3 is equal to 7. 3 plus 4 is equal to 7. 0 plus 6 is equal to 6. 6 plus 0 is equal to 6. So, the order of the numbers does not matter. For any two whole numbers a and b, a plus b is equal to b plus a. So, addition is commutative. Let's check for subtraction. 4 minus 3 is equal to 1. 3 minus 4 is equal to minus 1. 6 minus 0 is equal to 6. 0 minus 6 is equal to minus 6. So, when the order of numbers changes, the answer changes. Hence, subtraction is not commutative. Now let's check for multiplication. 4 multiplied by 3 is equal to 12. 3 multiplied by 4 is equal to 12. 6 multiplied by 0 is equal to 0. 0 multiplied by 6 is equal to 0. Here too, you can see that with any two whole numbers a and b, a multiplied by b is equal to b multiplied by a. So, multiplication is commutative. Now let's check for division. 16 divided by 4 is equal to 4. 4 divided by 16 is equal to 4 upon 16. So, when the order of numbers changes, the answer changes. Hence, division is not commutative. In the same way, you can check commutativity for integers. Addition is commutative. Subtraction is not commutative. Multiplication is commutative. And division is not commutative. Let's now check this property for rational numbers. The sum of two rational numbers remains the same no matter in what order they are added. 2 upon 7 plus 4 upon 7 is equal to 6 upon 7. 4 upon 7 plus 2 upon 7 is also equal to 6 upon 7. 9 upon 15 plus 2 upon 15 is equal to 11 upon 15. 2 upon 15 plus 9 upon 15 is also equal to 11 upon 15. So, addition is commutative. If a and b are two rational numbers, a minus b is not equal to b minus a. 3 upon 4 minus 7 upon 8 is equal to 6 minus 7 upon 8 is equal to minus 1 upon 8. Whereas 7 upon 8 minus 3 upon 4 is equal to 7 minus 6 upon 8 is equal to 1 upon 8. Minus 1 upon 8 is not equal to 1 upon 8. Let's take another example. 2 upon 3 minus 5 upon 6 is equal to 4 minus 5 upon 6 is equal to minus 1 upon 6. Whereas 5 upon 6 minus 2 upon 3 is equal to 5 minus 4 upon 6, which is equal to 1 upon 6. Minus 1 upon 6 is not equal to 1 upon 6. So, subtraction is not commutative. Now let's multiply 3 upon 7 and 5 upon 9. 3 upon 7 multiplied by 5 upon 9 is equal to 3 multiplied by 5 upon 7 multiplied by 9 is equal to 15 upon 63. Whereas 5 upon 9 multiplied by 3 upon 7 is equal to 5 multiplied by 3 upon 9 multiplied by 7, which is also equal to 15 upon 63. It doesn't matter what order the numbers are multiplied in, the product remains the same. So, multiplication is commutative. Now let's check commutativity for division. 8 upon 14 divided by 4 upon 2 is equal to 8 upon 14 multiplied by 2 upon 4 is equal to 2 upon 7. Whereas 4 upon 2 divided by 8 upon 14 is equal to 4 upon 2 multiplied by 14 upon 8 is equal to 7 upon 2. When the order of numbers changes, the answer changes too. So, division is not commutative. So, we've understood what commutativity is. Now let's see what associativity is. Associativity is like commutativity, but for 3 numbers. Let's check it out. Let's check associativity for whole numbers for the addition operation. Is 5 plus 4 into brackets plus 3 equal to 5 plus 4 plus 3 into brackets? Yes, no matter which 2 numbers you add first, the answer does not change. So, addition is associative. Now let's check associativity for whole numbers for the subtraction operation. Is 10 minus 3 into brackets minus 2 equal to 10 minus 3 minus 2 into brackets? 10 minus 3 into brackets minus 2 is equal to 7 minus 2 is equal to 5. Whereas 10 minus 3 minus 2 into brackets is equal to 10 minus 1, which is equal to 9. Both the expressions are not equal. So, what you do first matters. So, subtraction is not associative. Let's check associativity for whole numbers for the multiplication operation. Is 5 multiplied by 4 into brackets multiplied by 3 equal to 5 multiplied by 4 multiplied by 3 into brackets? Yes, no matter which 2 numbers you multiply first, the answer does not change. So, multiplication is associative. Now let's check associativity for whole numbers for the division operation. Is 32 divided by 8 into brackets divided by 2 equal to 32 divided by 8 divided by 2 into brackets? 32 divided by 8 into brackets divided by 2 is equal to 4 divided by 2, which is equal to 2. Whereas 32 divided by 8 divided by 2 into brackets is equal to 32 divided by 4, which is equal to 8. Both the expressions are not equal. So, what you do first matters. So, division is not associative. Let's check associativity for integers for addition operation. Is minus 2 plus 3 into brackets plus minus 4 equal to minus 2 plus 3 plus minus 4 into brackets? Minus 2 plus 3 into brackets plus minus 4 is equal to 1 minus 4 is equal to minus 3. And minus 2 plus 3 plus minus 4 into brackets is equal to minus 2 minus 1, which is equal to minus 3. Both the expressions are equal. So, addition is associative. Let's check associativity for integers for subtraction operation. Minus 2 minus 3 into brackets minus minus 4 is equal to minus 2 minus 3 minus minus 4 into brackets. Minus 2 minus 3 into brackets minus minus 4 is equal to minus 5 plus 4 is equal to minus 1. Whereas minus 2 minus 3 minus minus 4 into brackets is equal to minus 2 minus 7, which is equal to minus 9. Both the expressions are not equal. So, what you do first matters. So, subtraction is not associative. Let's check associativity for integers for multiplication operation. Is minus 2 multiplied by 3 into brackets multiplied by minus 4 equal to minus 2 multiplied by 3 multiplied by minus 4 into brackets? Minus 2 multiplied by 3 into brackets multiplied by minus 4 is equal to minus 6 multiplied by minus 4, which is equal to 24. And minus 2 multiplied by 3 multiplied by minus 4 into brackets is equal to minus 2 multiplied by minus 12 is equal to 24. Both the expressions are equal. So, multiplication is associative. Let's check associativity for integers for division operation. Is minus 54 divided by 9 into brackets divided by minus 3 equal to minus 54 divided by 9 divided by minus 3 into brackets? Let's take a look. Minus 54 divided by 9 into brackets divided by minus 3 is equal to minus 6 divided by minus 3 is equal to 2. Whereas minus 54 divided by 9 divided by minus 3 into brackets is equal to minus 54 divided by minus 3 is equal to 18. Both the expressions are not equal. So, what you do first matters. So, division is not associative. Let's check associativity for rational numbers. When adding more than two rational numbers, it doesn't matter which two numbers we group at a time. Let's take a look. 2 upon 7 plus 3 upon 7 into brackets plus 1 upon 7 is equal to 5 upon 7 plus 1 upon 7 is equal to 6 upon 7. And 3 upon 7 plus 1 upon 7 into brackets plus 2 upon 7 is equal to 4 upon 7 plus 2 upon 7 is equal to 6 upon 7. So, addition is associative. We can write it like this. A upon B plus C upon D into brackets plus E upon F is equal to A upon B plus C upon D plus E upon F into brackets, where B is not equal to 0, D is not equal to 0 and F is not equal to 0. So, addition is associative. The product of three rational numbers is the same even if the order of grouping of the numbers is changed. A upon B multiplied by C upon D into brackets multiplied by E upon F is equal to A upon B multiplied by C upon D multiplied by E upon F into brackets, where B is not equal to 0, D is not equal to 0 and F is not equal to 0. You can easily verify this. 2 upon 3 multiplied by 4 upon 5 multiplied by 2 upon 7 is equal to 2 upon 3 multiplied by 4 upon 5 into brackets multiplied by 2 upon 7 is equal to 8 upon 15 multiplied by 2 upon 7 is equal to 16 upon 105. And 2 upon 3 multiplied by 4 upon 5 multiplied by 2 upon 7 is equal to 2 upon 3 multiplied by 4 upon 5 multiplied by 2 upon 7 into brackets is equal to 2 upon 3 multiplied by 8 upon 35 is equal to 16 upon 105. So, multiplication is associative. Subtraction is not associative for rational numbers. Let's check. Is minus 2 upon 3 minus minus 4 upon 5 minus 1 upon 2 into brackets equal to minus 2 upon 3 minus minus 4 upon 5 into brackets minus 1 upon 2? Let's take a look. Minus 2 upon 3 minus minus 4 upon 5 minus 1 upon 2 into brackets is equal to minus 2 upon 3 plus 13 upon 10 which is equal to 19 upon 30. Whereas minus 2 upon 3 minus 4 upon 5 into brackets minus 1 upon 2 is equal to 2 upon 15 minus 1 upon 2, which is equal to minus 11 upon 30. So, subtraction is not associative. Division also is not associative for rational numbers. Let's take a look. Is 1 upon 2 divided by minus 1 upon 3 divided by 2 upon 5 into brackets equal to 1 upon 2 divided by minus 1 upon 3 into brackets divided by 2 upon 5? Let's take a look. 1 upon 2 divided by minus 1 upon 3 divided by 2 upon 5 into brackets is equal to 1 upon 2 divided by minus 1 upon 3 multiplied by 5 upon 2 into brackets is equal to 1 upon 2 divided by minus 5 upon 6 is equal to 1 upon 2 multiplied by minus 6 upon 5, which is equal to minus 6 upon 10. Whereas 1 upon 2 divided by minus 1 upon 3 into brackets divided by 2 upon 5 is equal to 1 upon 2 multiplied by 3 upon minus 1 into brackets divided by 2 upon 5, which is equal to minus 3 upon 2 divided by 2 upon 5, which is equal to minus 3 upon 2 multiplied by 5 upon 2, is equal to minus 15 upon 4.
What is closure property, commutativity, and associativity of the rational numbers? Now, we'll be looking at the role of 0. What happens when you add 0 to a number? Let's check for whole numbers, integers, and rational numbers. Add 0 to a whole number. 4 plus 0 is equal to 4. 0 plus 96 is equal to 96. The number remains the same. Add 0 to an integer. Minus 4 plus 0 is equal to minus 4. 0 plus minus 6 is equal to minus 6. The number remains the same. The sum of a rational number and 0 is the same rational number itself. 0 plus 6 upon 13 is equal to 6 upon 13. 4 upon 7 plus 0 is equal to 4 upon 7. 0 plus 5 upon 9 is equal to 5 upon 9. 6 upon 11 plus 0 is equal to 6 upon 11. 0 plus a upon b is equal to a upon b, where b is not equal to 0. Therefore, 0 is called the identity for the addition of rational numbers. That means when you add it to a rational number, the rational number remains unchanged. The product of a rational number and 0 is 0. A upon b multiplied by 0 is equal to 0, where b is not equal to 0. You can easily verify this. Minus 5 upon 9 multiplied by 0 is equal to 0. 0 multiplied by 8 upon 7 is equal to 0. 3 upon minus 11 multiplied by 0 is equal to 0. So, we've understood what the role of 0 is. Now, we'll be looking at the role of 1. Let's check for rational numbers and find out. The product of a rational number and 1 is the same rational number. You can easily verify this. Minus 5 upon 9 multiplied by 1 is equal to minus 5 upon 9. 1 multiplied by 8 upon 7 is equal to 8 upon 7. 3 upon minus 11 multiplied by 1 is equal to 3 upon minus 11. The product of a rational number and 1 is the same rational number. That means a upon b multiplied by 1 is equal to a upon b, where b is not equal to 0. 1 is called the multiplicative identity for rational numbers. That is because when we multiply a rational number by 1, we get the same rational number. So, we've understood what the role of 1 is. Let's check out the negative of a number. You know what the negative of an integer is. The negative of 3 is minus 3. The negative of minus 4 is 4. It's basically the additive inverse. When we add an integer to its negative, we get 0. Rational numbers have negatives too. When we add a rational number to its negative, we get 0. So, the negative is also called the additive inverse. Rational number 11 upon 36. The additive inverse is minus 11 upon 36. Rational number minus 7 upon 12. Its additive inverse is 7 upon 12. Rational number 6 upon 13. Its additive inverse is minus 6 upon 13. So, we've understood what the negative is. Let's check out the reciprocal of a number. Rational numbers have reciprocal. If a upon b multiplied by c upon d is equal to 1, then c upon d is the reciprocal of a upon b. You can easily find the reciprocal of a rational number by flipping the numerator and denominator. Remember, 0 has no reciprocal because 0 cannot be in the denominator of a rational number. Find the reciprocals of these rational numbers. 4 upon 7 gives us 7 upon 4. Minus 3 upon 4 will be minus 4 upon 3. Minus 2 upon minus 9 will be 9 upon 2. 1 upon 7 will be 7 upon 1 is equal to 7. 12 upon 19 will be 19 upon 12. 13 will be 1 upon 13. Answer these questions. The reciprocal of a rational number is a rational number. Does 0 have a reciprocal? No. What is the reciprocal of 1? 1. What is the reciprocal of minus 1? Minus 1. Is the reciprocal of a negative rational number also negative? Yes. A reciprocal is also called the multiplicative inverse. Why is that so? Because when we divide a rational number by the other, we take the reciprocal of the divisor and convert the division to multiplication. So, we can take the inverse to multiply. That inverse is the reciprocal and the use of it is multiplication. Hence, reciprocal is equal to multiplicative inverse. Get it? When we divide a rational number by 1, we get the same rational number. 8 upon 14 divided by 1 is equal to 8 upon 14. Minus 16 upon 70 divided by 1 is equal to minus 16 upon 70. When we divide 1 by a rational number, we get the reciprocal of the rational number. 1 divided by minus 6 upon 20 is equal to minus 20 upon 6. 1 divided by minus 16 upon 9 is equal to minus 9 upon 16. What's additive inverse? It's the negative of a number. What's multiplicative inverse? It's the reciprocal of a number. When you add a number to its additive inverse, you get the answer as 0. When you multiply a number with its multiplicative inverse, you get the answer as 1. Remember that properly without getting confused. Kidding, of course you won't, you're smart. So, we've understood negatives and reciprocals. Let's check out the negative of a number. Let's check out the last property, Distributivity. Distributivity is actually distributivity of multiplication over addition. It's easy to understand by just looking at it directly rather than just explaining in theory. Well, most of mathematics is that way. You just have to get it properly. Then it's all easy breezy. Look at this expression. We have a bracket, so we solve that first. Then we multiply and get the value. 5 upon 7 plus 6 upon 15 into bracket multiplied by 2 upon 5 is equal to 75 plus 42 upon 105 into bracket multiplied by 2 upon 5 is equal to 117 upon 105 multiplied by 2 upon 5 is equal to 78 upon 175. Now, look at this expression. We do the multiplication first and then the addition, and we get the same value. 5 upon 7 multiplied by 2 upon 5 plus 6 upon 15 multiplied by 2 upon 5 is equal to 2 upon 7 plus 4 upon 25 is equal to 50 plus 28 upon 175 is equal to 78 upon 175. Interesting. Let's get to the bottom of this. This is something that is going to help you a lot in mathematics that you'll do for years to come. We just found out that these two expressions mean the exact same thing. Basically, what has happened here is that when we open the bracket, that multiplying factor outside the bracket goes to each term inside the bracket. What if we had a subtraction inside the bracket instead of addition? Doesn't matter. It would still work. 5 upon 7 minus 6 upon 15 into brackets multiplied by 2 upon 5 is equal to 5 upon 7 multiplied by 2 upon 5 minus 6 upon 15 multiplied by 2 upon 5. Now, you may wonder, does this hold true for multiplication? Well, we know that whatever is multiplied to the bracket applies to each term inside the bracket. So, is this true? 4 upon 5 multiplied by 3 upon 7 into brackets multiplied by 2 upon 3 is equal to 4 upon 5 multiplied by 2 upon 3 into brackets multiplied by 3 upon 7 multiplied by 2 upon 3 into brackets? No! We said each term inside the bracket. Inside the bracket, we have 4 upon 5 multiplied by 3 upon 7. This is one term. Terms can be separated by addition or subtraction only. If there are numbers separated by multiplication or division, they are still one term. This is the mathematician's way of showing distributivity of multiplication over addition for rational numbers. A upon B plus C upon D into brackets multiplied by E upon F is equal to A upon B multiplied by E upon F plus C upon D multiplied by E upon F, where B is not equal to 0, D is not equal to 0, and F is not equal to 0. Did you understand the different properties of rational numbers? Yes!
Thank you for watching AHA நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை